I have decided to solve some very classic problems in numerical analysis for the students of this course. Before that, please subscribe my channel and try to watch online my lectures. Let me start with a very simple and very classic problem in numerical analysis, problem number 1. Let me state the problem. Let x0, x1, 2, xn be n plus 1 distinct points, and let Li of x for I equal to 0, 1, 2, n be the corresponding Lagrange polynomials. What do we want? Prove that. We want to prove two things. First, we want to prove sigma I from 0 to n. Li of x is equal to 1, and this is true for all x. And the second one, we want to prove something similar, I from 0 to n, x I to power of k. Li of x is equal to x to power of k for all x and for all k less or equal n. This is the problem. But the solution. Let me start to solve the problem. We know that the Lagrange interpolant polynomial is to form p of x equal to sum I equal to 0 to n f of xi Li of x is the interpolant polynomial for f, okay, in the nodal points that I mentioned here. Now, set f of x equal to 1, okay? Here I say that because degree of p of x is equal to n and degree of f of x, it should be less or equal, is equal to 1. So I know that p of x interpolate f of x rho f of x exact. It means that it's exactly interpolate function f of x equal to 1. Now, we write f of x that was equal to 1 is equal to p of x, and p of x is equal to sum I from 0 to n f of xi Li of x. But here, from here, we know that because f of x is equal to 1, so f of xi equal to 1 for I equal to 0, 1 to n, right? So I put here, instead of all f of xi, I put 1. I put 1. So I get sum I from 0 to n Lix, okay, and this is complete the proof. So sigma I from 0 to n Li of x equal to 1. This is the first part of the problem. And for the second part is very similar to the first part. Just I consider f of x equal to x to power of n. And also I know that p of x interpolate f of x exact, right? So I can write, and this one gives f of xi equal to xi to power of let me put here k instead of n. K, okay, for I equal to 0 to n, and all I know that f of x, which was equal to x to power of k, is exactly equal to p of x, and this is equal to I from 0 to n f of xi Li of x. And here I put, instead of f of xi, instead I put xi to power of k, and this is equal to sum I from 0 to n xi to power of k Li x. Okay, and this gives sigma I from 0 to n xi to power of k Li of x is equal to x to power of k for all k less or equal n. But when k is, for example, equal to n plus 1, or in general form k is bigger than n, this is not true, because in this case the interpolant Pn of x has a degree of n plus 1, and x is Pn of x has a degree of n, and f of x has a degree of n plus 1, and they cannot be same, and this is over. So I would prefer to solve every problem in each lecture. I solve one problem. So let me stop here and ask you please to follow my channel.